Let's quickly understand what is Bernoulli's equation and what are its limitations. So, Bernoulli's equation is a fundamental principle of fluid mechanics that relates the pressure, velocity, and elevation of a fluid flowing through a streamline. It is based on the law of conservation of energy, which simply means that the total mechanical energy of a fluid remains constant as it flows, and if there is no friction or energy loss. So in short, Bernoulli's equation states that for an ideal, incompressible, and non-viscous fluid flowing in a steady flow, the total energy, which includes pressure energy, kinetic energy, and potential energy, per unit weight remains constant, along a streamline. Mathematically, in standard form, Bernoulli's equation can be written as P by rho g plus V square by 2g plus z is equal to constant. And Bernoulli's equation between 2 points can be written as P1 by rho g plus V1 square by 2g plus z1 is equal to P2 by rho g plus V2 square by 2g plus z2, where P is pressure energy per unit volume in n square, rho is density of fluid, V is velocity of fluid in meter per second, g is acceleration due to gravity in meter per second square, z is the elevation height in meter. So basically, the first term, that is P by g, represents the pressure head. The second term, that is V square by 2g, represents the velocity head, and the third term, that is z, represents the elevation head. And their sum remains constant for an ideal fluid. But in real life, fluids are not ideal. They have viscosity, friction, and energy losses. So Bernoulli's equation has some limitations, such as it's not valid for viscous or real fluids because frictional losses are ignored. Then, it cannot be applied in turbulent or rotational flow, only in smooth, laminar flow. It doesn't work for compressible fluids, like gases, where density changes with pressure. Then it doesn't include energy addition or removal, so pumps, turbines, or heat transfer are not considered. And finally, it cannot be used for unsteady flow, where velocity or pressure changes with time.